It is roughly 384,000 kilometers from Earth and was last seen by humans 53 years ago in 1972. What transpired next is really something to think about. We never even tried to go back. But now, in 2026, we are getting ready to visit the Moon once more. This time, the objective is not just to visit, but to remain, build a settlement, and even more ambitious to reach Mars. Arguably the most ambitious space endeavor in human history, the overall endeavor is called the Artemis mission. The most important question still stands though. If we were able to reach the Moon in 1969, why didn't we go back for another 50 years? Is it really so hard to get to the Moon? Or is there another explanation for this? We will investigate what the Artemis mission comprises, how it functions, and why it is so vital to our future now, in an effort to find the answer to this very issue. Let's first go back a little in time. The United States and the Soviet Union were engaged in what we now refer to as the space race throughout the 1960s. During that period, both countries tried to show each other who was more technologically advanced. The United States trailed behind the Soviet Union when they launched Sputnik, the first satellite, and Yuri Gagarin, the first human into space. As a result, US President John F. Kennedy boldly declared in 1961 that the US would land a human on the Moon and return them safely to Earth before the decade came to an end. The Apollo program started as a result. Now, as it can be challenging to appreciate Artemis without first understanding the context of its predecessor, let's take a moment to understand the Apollo program. There were 17 missions in the Apollo program. Apollo 11 is the most well-known of these, as Neil Armstrong's first lunar landing occurred on the 20th of July 1969 during this mission. When Neil Armstrong said, "That's one small step for a man, one giant leap for mankind," everyone around the globe was glued to their televisions that day. After that, astronauts visited the Moon on the Apollo 12, 14, 15, 16, and 17 missions. A total of 12 people have set foot on the Moon. But everything stopped after Apollo 17 inches 1972, and we never went back. When one hears this, the question of why, precisely, comes to mind. Has technology ran out? Has the money stopped coming in? Or did the interest just wane? In actuality, each of the three explanations is sound. You see, defeating the Soviet Union was the main purpose of the space race, and it was accomplished when the United States made a successful Moon landing. The public's interest then started to decline since they believed that the Moon was the destination and that there was nothing else to see. Additionally, the government cut the budget as public interest declined. Calculated in today's currency, the Apollo program cost over $280 billion. This is an enormous amount of money, and it proved to be politically untenable to spend that much money without any apparent demonstrable rewards. In other words, the endeavour to reach the Moon only decreased in importance rather than truly ceasing. But today, 50 years later, the environment is entirely different. Going to the Moon is now the next evolutionary step for all of humanity, rather than a race exclusive to one country. And the main reason for this is that we now understand that the Moon is more than just a desolate sphere of rock. Rather, it has something that has the power to drastically change the course of space research going forward, and that something is water. You read correctly, water exists on the Moon. But this water does not exist as it does on Earth. Rather, it exists as ice, that is, near the south pole of the Moon, inside craters that are inaccessible to sunlight. Furthermore, this finding is a real game changer. You may be asking yourself, what is the real impact of discovering water on the Moon? So, let's simplify this as much as feasible. Look, what covers the majority of the expenses when we launch something into space? It is the effort required to lift weight against the force of gravity. Because of Earth's powerful gravitational pull, it takes a lot of fuel to launch anything into space, and water is very heavy. The weight of 1 litre of water is precisely 1 kilogram. Astronauts need water for drinking, growing food, and most importantly, making fuel if they plan to go on extended space trips. It is possible to turn water into fuel. Water has the chemical formula H2O, which stands for 2 hydrogen atoms and 1 oxygen atom. We can separate the hydrogen from the oxygen by disassembling it using a procedure called electrolysis. The astronauts use the oxygen for respiration, and the hydrogen is used as rocket fuel. Consequently, if we are able to obtain water directly from the Moon, we will not need to ship such large amounts from Earth, which will significantly lower the total cost of these missions. The Artemis mission enters at this point. NASA's Artemis mission will return humans to the Moon, but this time the objective is to establish a permanent presence there rather than just visit. Greek mythology, where Artemis was Apollo's twin sister, is where the name Artemis originates. A woman and a person of colour will land on the Moon for the first time, which is why this name was picked. To put it another way, this expedition is not only about research, but also conveys the idea that space travel is accessible to all. Let's now divide the Artemis program into 3 sections to better comprehend it. Artemis I is the first finished in 2022. The second is Artemis II, which is scheduled to happen shortly. And the third is Artemis III, when people will truly set foot on the Moon. Let us first discuss Artemis I. Launched in November 2022, this mission was unmanned, meaning no people were on board. This mission's goal was to test NASA's new Orion spacecraft and rocket, the SLS. The Space Launch System, or SLS for short, is NASA's most potent rocket to date. Compared to the Saturn V used for the Apollo missions, this rocket is even more potent. With a height of 98 meters, or about the height of a 30-story building, with a thrust or propulsive force of 39.1 meganewtons, the SLS has the capacity to defy Earth's gravitational pull. Let's now discuss the Orion spaceship. Astronauts will go to the Moon aboard a capsule called Orion. This capsule can hold 4 astronauts and is bigger than the Apollo capsules. It can survive in space for up to 21 days without replenishment, thanks to its sophisticated life support system and radiation shielding. The Orion spacecraft successfully completed a 25-day orbit around the Moon as part of the Artemis I mission. We are now prepared to launch humans into space, since this mission effectively proved that the Orion spacecraft and the SLS rocket are both completely operational. Let's now talk about Artemis II, which is the program's next significant development. Humans will board the Orion spacecraft and orbit the Moon for the first time during this mission. A crew of 4 astronauts will travel on this trip, which is anticipated to last roughly 10 days. However, this mission is essentially a test trip intended to confirm whether humans can live and function within the Orion spacecraft safely. It will not involve a landing on the lunar surface. Since Canada is a crucial partner in this mission, 1 Canadian astronaut is part of the team chosen for Artemis II. The series' most thrilling mission, Artemis III, follows. Humans will set foot on the lunar surface for the first time in 50 years on this mission. This mission is also noteworthy because it will be the first time a woman and a person of colour land on the Moon. But there is much more to this endeavour than just going to the Moon to place a flag. This time, the astronauts will visit the south pole of the Moon, an area never visited by humans. They will gather samples, examine water ice, and try to figure out how a permanent lunar base might be built there. Now, Artemis differs from the Apollo program in one intriguing way. 1 spacecraft was in charge of the entire trip to the Moon during the Apollo missions. But under the Artemis program, a different vehicle called Starship, built by SpaceX, will be utilised only for the lunar landing. Yes, SpaceX, Elon Musk's business, is involved in this endeavour. The biggest and most potent rocket ever constructed is called Starship. It is 120 meters tall and completely reusable, which means it may be used again after one use. The Artemis III mission will take place in the following order. The Orion spacecraft will first be launched into lunar orbit by the SLS rocket. Starship will already be there, having been launched separately into lunar orbit. After that, the astronauts will go from Orion to Starship. They will be taken to the lunar surface by Starship. There, they will carry out their operations. Starship will then put them back in orbit. Orion will then return them to Earth. This task is being carried out step by step because it is so complicated. What will we actually do when we get to the Moon? Let's examine it. NASA intends to build what is now known as the Artemis Base Camp, a permanent base on the Moon. Water ice is known to exist at the Moon's south pole, where this facility will be built. Astronauts will be able to reside, carry out research, and get ready for extended missions at this station. But a base won't be created only on the ground. A space station called Gateway will also be constructed in lunar orbit. A smaller space station called Gateway will orbit the Moon. Though it will be smaller, its idea will resemble that of the International Space Station. Its main purpose will be to act as an astronaut stopover. To put it another way, any mission headed for the Moon will first make a stop at Gateway before descending to the surface. Most significantly, the European Space Agency, Japan, Canada, and a number of other countries are partners in Gateway, so it won't be a NASA-only initiative. A crucial question now emerges. What are the advantages of doing all of this? It will cost billions of dollars to build a base on the Moon. What is the investment's return then? Mars is the solution. Indeed, reaching Mars is the real goal of travelling to the Moon. As you can see, Mars is a long way from Earth. Even at their closest point, Earth and Mars are still roughly 55 million kilometers apart, and the trip takes 7 to 9 months. It is now very challenging to launch such a long-duration mission straight from Earth. On the other hand, we could launch our expeditions to Mars from the Moon if we had a base there. Compared to Earth, the Moon's gravity is 6 times weaker. This implies that much less fuel would be needed for a launch from the Moon. Furthermore, it would be considerably simpler and less expensive to travel to Mars if we had the means to create fuel on the Moon. In other words, the Moon is effectively a stepping stone to Mars. It's crucial to recognise that living on the Moon is a difficult task. Astronauts would have to overcome many obstacles. Temperature is the first obstacle. Temperatures on the Moon can reach as high as 127 degrees Celsius in sunlight-exposed regions and as low as negative 73 degrees Celsius in shaded places. It is quite tough to survive in such severe temperatures. Radiation is the second problem. The Moon doesn't have an atmosphere that can protect it from cosmic rays and solar radiation. Human health is seriously threatened by this radiation, which can cause diseases like cancer. Dust is the third obstacle. Regolith is a very fine and abrasive dust that can be found on the Moon. It can enter spacesuits, cause damage to equipment, and enter the lungs through inhalation. This dust caused astronauts to face serious challenges throughout the Apollo missions. Gravity is the fourth obstacle. Compared to Earth, the Moon's gravity is 6 times weaker. Long-term exposure to low gravity weakens bones and atrophy muscles. NASA and other organisations are presently developing methods to deal with all of these issues. Let me now reveal an intriguing secret that you may not know. America is not the sole participant in this race. China is also aggressively pushing its lunar program. China successfully landed a spacecraft on the Moon's far side, the hemisphere that is never seen to humans from Earth for the first time in 2019, with its Chang'e 4 mission. Later, samples were recovered from the Moon by the Chang'e 5 mission, and samples were particularly returned from the far side by the Chang'e 6 mission, a previously unattainable feat. By 2030, China wants to send people to the Moon and set up a permanent base there. Furthermore, China is not working alone on this project. It has partnered with Russia to build an international lunar research station. In essence, a new space race has started, with extremely high stakes, and India is undoubtedly not falling behind. ISRO achieved a historic soft landing on the Moon's south pole in 2023 with the Chandrayaan-3 mission. India became the first country to arrive precisely at the South Pole and the fourth to successfully accomplish a soft landing on the Moon. This was a huge accomplishment because landing at the South Pole is much harder than landing at the North Pole. There are many craters and rough terrain, making it difficult to maintain communication lines. However, ISRO succeeded in this endeavour, and the world took note. ISRO is now developing the Gaganyaan mission, which will send Indian humans into space for the first time. After that, ISRO intends to work with NASA on a collaborative mission to the Moon. The prospect of sending Indian astronauts to the International Space Station has been agreed upon by NASA and ISRO. Additionally, India may eventually take part in the Artemis missions. Now pause to think about why this is all so crucial. What is the point of spending billions of dollars on space when we already have so many issues on Earth, such as poverty, conflict, and climate change? And while it is a legitimate question, there is an answer. Look, many of the technology that we use on a daily basis today were developed during the Apollo missions. NASA initially developed the memory foam in your mattress for use in spacesuits. Your home's water purifying system was created for space travel. The results of space research include insulating materials, freeze-dried meals, cordless equipment, and scratch-resistant eyewear. Thus, the money invested on space is not squandered. It stimulates the economy, produces new technology, and adds jobs. The economy received a $7 to $14 return for every dollar spent on the Apollo program. The most crucial argument is that human nature is inherently exploratory. We left Africa and travelled all over the world. We climbed mountains, traversed oceans, and found new islands. And now there's nothing more to discover on Earth. Space is the next step. The entire universe lies beyond the Moon and Mars. We must travel beyond Earth if we want to continue as a species. Because anything may happen, a supervolcano could erupt, an asteroid could strike, or anything else, and our entire civilization might be destroyed if we stay on Earth. On the other hand, our survival is assured if we develop into a multiplanetary species, and the first significant step in that direction is the Artemis mission. That concludes the tale of Artemis. After landing on the Moon in 1969, we seemed to forget about it for 50 years. However, we are returning today, and this time our intention is to stay rather than merely visit. The objective is to set up a base on the Moon, carry out research, and then send missions to Mars. It will take years to realize this enormous project. But every big project starts with a single tiny step, and Artemis is just that. When you hear in the news in the upcoming years that the first lunar base has been constructed, or that the first woman has set foot on the Moon, keep in mind that these events are part of a dream that started 60 years ago, and we are all witnesses to this momentous occasion. That concludes the Artemis mission story. I hope you now know what this mission involves, why it is important, and how it will affect our future. Please share this video with your friends, like it, and subscribe to the channel if you liked it. I'll see you in the upcoming video, which will cover yet another interesting subject. Until then, maintain your curiosity and continue to consider space.